Welcome to the network design POC for a tier 2 ISP. Now, what does a tier 2 ISP mean? A tier 2 ISP is an internet service provider which gives access to the internet via the tier 3 ISPs, which are smaller ISPs that actually connect to the endpoints, and is also connected to a tier 1 ISP, which has all the internet routes. So it is essentially a bridge between tier 3 ISPs and the larger tier 1 ISP. Now, this diagram here shows you one of the sites of a tier 2 ISPs. And what we are trying to do here is how do we provision this network within a few clicks? To understand that, let's look at this diagram. On the leftmost side, you have your NMAS, which is essentially your network management automated system. Now, that could be on your AWS cloud or it could be on your private cloud or any cloud. And that is connected to a edge router. Now, it doesn't matter for this design purposes what that edge router does. It's essentially the edge of your network which is connected to the AWS cloud. That edge router essentially is connected to a management switch, and the management switch connects to the DHCP server, which could also act as a TFTP server for zero touch provisioning. Management switch also connects out of band with the actual transit network of the ISP. In this diagram, at each layer, we have only considered one router. However, no matter how many routers we add on each layer, we just need one connection from the management switch to all of these routers. The topmost layer is the tier 1 edge, which essentially connects to the tier 1 ISP's edge router. In the middle, we have the core router. And below that, we have the tier 3 edge, which connects to the tier 3 ISP's edge router. It's a simple enough design topology, but there's a lot of configuration to be done. There's BGP, there's MPLS, there's iBGP as well as eBGP, and actual IP configuration that is to be done on the routers. How do we do that in a single click? Let's take a look at that now. All right, let's say you just got the delivery of your routers. You scan their RFID tags and you get the MAC address mapping, and you create this file that you're seeing here. As soon as you push this file to Git, this automatically triggers a Jenkins job. The Jenkins job has a webhook built into it that gets triggered automatically as soon as this file is pushed into Git. But what does this Jenkins job actually do? This Jenkins job is a CI/CD pipeline which does three things. The first thing, it configures the DHCP server itself. Why does it configure the DHCP server? Because we need to have predictable IPs for the MAC addresses that we provided. This essentially just configures the DHCP pools with the MAC address to IP address mapping so that using ZTP, we can automatically assign an IP address to these devices and we know what IP address would be assigned. The second thing is checking the connectivity. Are we able to ping all three of these devices? And as you can see, it was successful. The third thing is configuring the actual transit network. This is where your BGP, your interface config, your MPLS, your iBGP, everything gets configured. And the beauty of it is that all of this is done via Jenkins templates or Jinja templates. So the entire design is vendor agnostic. If you choose to go with one vendor over other, the design will still work. As you can see, after the configuration is complete, we get a mail saying that it's successful. So we go to the website. Now, what good is the ISP before onboarding the tier 1 ISP and the tier 3 ISP? Right now, you just have your core configured. But as I am saying it, we have already configured a tier 1 ISP's IPv4. Now we are adding a tier 3 ISP's IPv4 interface. Just 4 steps, and this will create your BGP session, your interface configuration on that particular interface, and advertise the correct default route to that customer. Not just that, there is extreme flexibility to have either IPv4 only, IPv6 only, or both, depending on the customer that you have. Tomorrow, if a customer comes to your tier 2 ISP and asks you, how long will it take for us to get onboarded? It is exactly the 5 seconds for which I was talking about it. That's it. All of your tier 3 ISPs, IPv4 and IPv6, plus your tier 1 ISP, IPv4 and IPv6, is onboarded. So we go back to the diagram. We go back to the diagram and we can check that in the router which is connected to the tier 3 ISP, we can see that the BGP is already up. All of this was purely done via code. But how do we check if that code actually worked? How do we actually check if the internet connectivity is provided to tier 3 ISPs? You do a ping to internet. You do a ping 8888 and sources the source IP of that same router. And well, it works. And we're going to do it one more time just to get that 100% ping. But that's not all. We also need to do IPv6. So you're going to ping an IPv6 address from a source of IPv6 address and check if that works. And voila, that works too. There, you have your internet connectivity. Within 5 seconds, you have deployed your entire ISP tier 2 site at any given location. And you have provided internet access to your tier 3 ISPs within an instant. Thank you so much.